So nice job on task 34. You did it. Okay, let's move on to 36, array replace. Given an array of integers, replace all occurrences of an element to replace with substitution element. Okay, so for example, they've got this array here that contains the integers 1, 2, and 1. We want to replace 1, we want to replace it with 3, so then we get 3, 2, 3 instead of 1, 2, 1. Okay, yeah, seems doable. Seems doable. There are a few ways we could do this one. So I guess let's just start with the most literal interpretation again. We'll do something like actually, we can do this using some pretty nice syntax. For const num of input array. So I really like these for of loops, especially because they allow you to use a constant for the variable we're using to represent the element of the array. That's nice. You might think that's weird, you know, because it's like, aren't we reassigning it each time? The idea, as far as I understand, is that we're kind of making a new constant to refer to that element. So first the constant num would be 1, then constant num would be 2, then constant num would be 1. It's just like in here, if we were to do, you know, const num 2 is assigned the value of num plus 1, let's say, you know, like same sort of thing. It's kind of like putting the constant inside the loop there. Okay, so let's see. What do we want to do with this? Well, I guess basically we'll just say, ooh, maybe this won't work. Okay, let's do it this way first. So this is a good opportunity. Const, we'll call it replaced array, and we'll start it out as just this empty array. And then at each step, we're going to say replaced array dot push, and we'll say num equals substitution element. If it is, sorry, not substitution element. Is it the element we're trying to replace? If it is, then let's give it substitution element. If it's not, just give it whatever element it was, you know, give it num. Okay, and then at the end, we'll just return replaced array. Let's try that. Okay, seems to be working, not too bad. Yeah, this is kind of neat. It's illustrating a couple things here, so we'll just wait for this guy to fly away so we can hit the X and not move on to the next task quite yet. But basically the idea here is that, notice in this case, the ternary operator is happening inside something else. So like the way we did this last time is we had a return statement followed by the ternary. This time we're saying replaced array dot push, so it's actually inside, like as the argument of a function, we're putting in this ternary. So are we going to call dot push using substitution element, or are we going to call it using num? That's the question we're asking here. And what does it depend on? Well, whether or not our num was equal to the element we're trying to replace. Makes sense. Okay, so that's nice. That's one way to do it. It passed all the hidden tests and everything, so I respect it. I think it's worthy of commemorating here. So now I want to do it in a actually very, very similar way, except I want to illustrate this concept of, I don't know what the opposite of it is called, but what I'm about to do is, I think it's called modifying the array in place. So the idea is that we're not creating a new array. We're not going to reserve any more spaces in memory or anything like that. We're just going to modify the existing array. So we'll say for let I be assigned the value of 0, I is less than input array dot length I plus plus. And you might be wondering, why are you using a let here and not a const? And why are you not using a for of loop? Both of those are good questions. The reason I'm not using the for of loop is because I need more than just the element itself. I want to know what its index is, and we'll talk about why that is in just a sec. The reason I'm using let in this case and not const is because we are going to be changing the value of the variable I. Notice here how it says I plus plus. So that means we do need to change I. On the first run of this loop, we're going to be instantiating I as this new variable. Now over here, we're basically just making a constant that's num, and it's only going to last for the duration of this one iteration. The next iteration will have a new constant called, well, the same thing, but that's fine because it's limited to the scope of that one iteration of the loop. Okay, going back to this up here. So why do I need the index? Well, it's basically this, because we could say like const num is assigned the value of input array at I. So that's basically what this is doing for us. It's sort of like skipping the step of making I and then doing const num as input array I, or whatever you want to call these things. But anyway, that's the idea there, in case anyone was wondering about the const versus let. This was an issue that really confused me when I was first learning about const, so figured I'd mention it. Anyway, when we're looking at this, what we want to ask ourselves is, okay, I guess we'll do it this way. If num is element to replace, then we'll say input array at I is assign the value of substitution element. Yeah, so we'll actually modify the array itself instead of just filling up this new array over here, because presumably most of it is going to be the same. Presumably most of the time we're not going to have to make this substitution, right? And then at the end we'll just return input array. Technically it's an output now, but that's fine. So there we go. So that's the difference if we want to make the modification in place versus, I don't know what you call it, like I said, but not in place, I guess. Hopefully I'm using the right terminology when I say in place anyway. I don't know. I'm pretty sure I saw that in one of the, or some of the interview practice challenges for like the arrays section. So I get the sense that it's generally better for memory to not instantiate a new array if we don't have to. You might be looking at this and saying, well, yeah, but I don't like this kind of loop. Well, we need to use this kind of loop. The reason we need to use it is the reason we need to use it is because we need to do this. It's not good enough to just say num is assigned the value of substitution element. Partly because, well, it's a constant, but mainly because num is just the number. You know, num is saying, okay, well, it's a 1. Okay, so num is just 1. Num, as soon as it takes on the value 1, it has no more allegiance to this array. It's not going to remember what element or what index it came from. It just remembers what the number itself was. So modifying num is not going to do what we want it to. We need to say input array at I. So we do need to know the index of the element. Now, if you really, really don't want to use this structure for loops, if you're absolutely totally allergic to it, I believe there's a way we could do that. So, yeah, I think, because let me try this. Return input array, how does this go? Is it object.entries? I think it's something like that. Object.entries of input array, or is it just input array.entries? Am I just thinking of how we would deal with an object? Let's see. Oh, yeah, that looks like it was the one. Yeah, because we have the index and the element itself. It doesn't work like this, does it? No. Okay, so again, it's the difference between that, you know, the two different levels of methods there. But anyway, is it object method? Is that what they're called? I don't know. It's something like that. Anyway, so we'll use entries. So object.entries. So the way we're going to do this, because let me get that back on screen actually. .entries of what was input array. Okay. So when we return this, something to notice is that, yeah, there we go. We have the index or the indices, and we have the elements themselves as well. So we could do something like this, which maybe some of you would find a little slicker. We could say const index and num, okay? Or I'll just make it I, because that's what we're using down inside the actual loop there, of object.entries. What is it called? Input array. I don't know why I keep forgetting that. Okay, so, and are we balanced in parentheses? Yeah, that looks good. Let's close that out. We'll run the tests on that. And yeah, in fact, I don't think we need this now, right? So, okay, not bad. And this is just one line, so that could fit right there. I mean, technically, like now this is one line, so we could move that up there too, but no, that would be chaotic. Okay, cool. So yeah, that works. That's a way of doing it in place. Now, again, I don't know about this, if this is totally clear to the reader. Who knows? But it's a way we can do it. So, cool. We can use a for of loop in a lot of different ways, it turns out. All right, so we'll say that that's going to be arrayReplace 2. We're going to highlight the whole thing. We're going to cut it all out. We're going to reset the code. And looks like Rainbow Sprinkles here read our minds, because we are about to use sort of a string-based method for getting this. So basically we're going to convert this to a string, first of all. How are we going to convert it to a string? By doing a dot join. So we'll do input array dot join. Okay, we can run that. And okay, now it's like 1, 2, 1, 1, 2, 3, 4, 5. Now, is that okay to do that? Ooh, you know what? It might not be, because I'm noticing that these can be equal to 10. So that'd be 2 digits. That might not work, because we gotta have a 1, a 0, a 10, right? So might not totally work, but let's try it. So we've got this thing, it's a string right now. We wanna do a replace on this, and then we're gonna do like, I guess, a dot split at the end, or at least something to convert it to an array. So I guess I'll do it this way. I'll put the spread operator in the front. Now, here's the issue. We want to replace element to replace. We want to replace it with substitution element. Let's see what happens when we run that. Well, it's going to replace the first one, but not all of them. So, okay, that didn't quite work out for us. This one, it did do the right replacements, but there are a whole bunch of strings. We want them to be integers, right? So, well, we know how to deal with that. We've done that before, I think in the previous one, right? So we'll just do a little parse int on all these things. And there we go. Okay, so we've got this. Ooh, yeah, okay, that's good suggestion, Rainbow. We're gonna look at that in just a sec. But before we do, we need to deal with this. The fact that it's only replacing one of the ones here. We want it to replace all of them, right? So it's not really enough to just do lm to replace. What we have to do is make it something that's gonna clearly say, replace all of them. Make it global, right? Well, sounds like the global flag to me on a regular expression. Let's use a regexp. So we'll say new regexp. We're going to have to do it this way. Wait, do I need to capitalize the E? I can't remember. Let's just make it ABC for now, and we'll just, we'll return that. Okay. Oh, not what we're looking for? Well, let me just make sure. Let re be assigned the value of that, and we'll just do return re.test a, b, c, d, e, f, g. Let's try that. That should return true. Yeah, okay. Whereas if it was, I don't know, just like D, E, F, G, let's say, we'll run that, and that should be false. Yeah, okay, so that seems to be working. Now, you might be wondering, like, why would you do it that way? Why wouldn't you just say let regular expression be literally like just this? Isn't that like a lot easier? Well, yeah, it's a lot easier, but it's not going to work for us because we're using a variable here, lm to replace. Whereas if we were to try to just jam that in there, it'd say, okay, so we're looking for something with a lowercase e followed by a lowercase l followed by another lowercase e and then a lowercase m, then an uppercase t, etc. That's not what we want. We want the actual value of lm to replace. So in this case, we want 1. So this is more what we're looking for. Okay, so that's good, right? That's kind of, well, let's see. So we'll put re in there and we'll see if it works any better now. Well, no, it doesn't, because I still haven't put the global flag on. So let's give that as a second argument here, a string G. Keep that in mind. Misconception would be to put in just the G, but then it would be like, well, what's variable G? I don't see anything in the namespace. So, okay, we'll run that, and yeah, as suspected. So now it's getting all these. It's getting all of these. It's all working, except the 10s. It's giving us an issue, right? Because we have 1, 1, 1. We want to replace it with all these 10s here. So that's not quite going to work. So instead, we're going to use a suggestion from our guy, Rainbow Sprinkles. First, let's just make that a constant. And Rainbow said, hey, why don't you just put like a comma or some other character in the join there? So if we do that, then maybe that would work a little better. Okay, not totally working better because of I think the way we're putting it together. So we actually want to split this using the same thing. So we'll do dot split at the commas. Right? Can we do something like that? Yeah. Okay, so that's working. Good. Okay, so we actually did need to use dot split in this case and not like a spread operator with an array literal. So cool. Nice stuff. All right, let's submit that one. Let's see if it passes. Yeah, it passed the hidden test. Okay, cool. Any other ways we want to do this? I don't know. I think I'm probably okay with this. There's one more way. There's one more way. Let's do it one more way. Let's highlight all that. We'll cut it. We'll reset the code. We'll confirm. We'll do 1,000 enters and we'll paste it back in. Okay, so what do we want to do here? I want to try to be as direct as possible with this one. So basically what I want to return is going to be input array dot map. We're going to map each element to the following. Is it equal to element to replace? And if it is, give it substitution element. Otherwise, just give it whatever it was. Let's try running that. Is that going to work? Yeah, it works. Okay, cool. Let's just make sure it passes the hiddens. I'd say that's probably the most direct way to do this one. And it is also in place, like this one down here, because it is modifying the actual array. Now, in terms of which one would execute faster or, you know, be better in terms of space complexity, I'm not really sure. We'd have to do some tests. But for now, I'm okay to just move on from this one. So let's move on from this one. All right, nice job, everyone. You did it.